Good morning, everyone. My name is B. Varun. I am from CSC D section. Today's my tech talk topic is web scraping with Python. Contents in my topic are as follows: Introduction to web scraping using Python, history, a brief list of Python libraries used for web scraping, practical implementation, conclusion. Let's know about what is web scraping. Moving on to the next slide. Introduction to web scraping using Python. It is basically a technique or a process in which large amounts of data from a huge number of websites is passed through a web scraping software coded in a programming language, and as a result, structured data is extracted, which can be saved locally in our devices, preferably in Excel sheets, J- JSON, or spreadsheets. Now we don't have to manually copy and paste data from websites, but a scraper can perform that task for us in a couple of seconds. It is a form of copying in which specific data is gathered and copied from a website, typically into a central local database and spreadsheet for lateral retrieval or analysis. Moving on to the next slide. Python is mostly known as the best web scraper language. It's more like an all-rounder and can handle most of the web crawling related processes smoothly. Scrappy and Beautiful Soup are among the widely used frameworks based on Python that makes scraping using this language such an easy route to take. Web scraping a web page involves fetching it and extracting it. Fetching it is the downloading of a page, which a browser does when a user views a page. Therefore, web crawling is a main component of web scraping to fetch pages for later processing. Once fetched, once fetched, the extraction then takes place. The content of a page may be parsed, searched, reformatted, its data copied into a spreadsheet, or loaded into a database. Moving on to the next slide, web scrapers typically take something out of a page to make use of it for another purpose somewhere else. An example would be to find and copy names and telephone numbers or companies and their URLs or email addresses to a list. Contact scraping. Web scraping is used for scraping and as a component of applications used for web indexing, web mining and data mining, online price change monitoring and price comparison, product review scraping to watch the competition, gathering real estate listing, weather data monitoring, website change detection, research, tracking online presence, reputation, web, ma- web mashup, and web data integration. Moving on to the next slide. History. The history of web scraping dates back nearly to the time when World Wide Web was born. After the birth of World Wide Web in 1989, the first web robot, World Wide Web Wanderer, was created in June 1993, which was intended only to minimize the size of the web. In December 1993, the first crawler-based web search engine, JumpStation, was launched. As there were not so many websites available on the web, search engines at that time nearly used to rely on their human website administrators to collect and edit the links into a particular format. In comparison, JumpStation bought a new leap, being the first www search engine that relied on a web robot. In 2000, the first web API and API crawler came. API stands for Application Programming Interface. It is an interface that makes it much easier to develop a program by providing the building blocks. In 2000, Salesforce and eBay launched their own API with which programmers were able to access and download some of the data available to the public. Since then, websites offer web APIs for people to access their public database. Moving on to the next slide, a brief list of Python libraries used for web scraping. Requests library for web scraping. It is used for making various types of HTTP requests like GET, POST, etc. It is the most basic yet the most essential of all libraries. Next one, LXML library for web scraping. LXML library provides superfast and high performance parsing of HTML and XML content from websites. If you are planning to scrape large data sets, this is the one you should go for. Next one, Beautiful Soap library for web scraping. It works it work involves creating a parse tree for parsing content. A perfect starting library for beginners and very easy to work with. Moving on to the next one, Selenium library for web scraping. Originally made for automated testing of web applications, this library overcomes the issues all the above libraries face, that is, scraping content from dynamically populated websites. This makes it slow and not suitable for industry level projects. Next one, Scrapy for web scraping, the boss of all libraries. An entire web scraping framework which is as acrimonious in its usage. This makes it blazing fast and increases efficiency. Moving on to the next slide, practical implementation. Steps in web scraping using Python. First, document load, then parsing, then extraction, then transformation. Moving on to the next slide, Practical implementation. Step 1. How to use Python for web scraping. We need Python IDE and should be familiar with the use of it. Virtualenv is a tool to create isolated Python environments. With the help of Virtualenv, we can create a folder that contains all necessary executables to use the packages that our Python project requires. Here we can add and modify Python modules without affecting any global installation. We need to install various Python modules and libraries using the pip command for our purpose. But we should always keep in mind that whether the website we are scraping is legal or not. Moving on to the next slide. Requirements. Requests. It is an efficient HTTP library used for accessing web pages. URLib3. It is used for retrieving data from URLs. Selenium. It is an open source automated testing suite for web applications across different browsers and platforms. Installation. pip install Virtualenv, Python m pip install Selenium, Python m pip install requests, Python m pip install urlib3. Moving on to the next slide. Step 2. Introduction to Requests Library. Here we will learn various Python modules to fetch data from the web. The Python request library is used to make download the web page we are trying to scrape. Requirements: Python IDE, Python modules, requests library. This is the input we give in the Python IDE. Hashtag import required modules. Import requests, hashtag get URL. Page is equal to requests.get.codes https://en.wikipedia.org/wiki.main_page codes close bracket. Hashtag display status code. Print bracket page.status_code bracket. Hashtag display scraped data. Print page.content. Here we enter this code in the Python. This is the input we give. And moving on to the next slide. This is the output we get from it. The first thing we will need to do to scrape a web page is to download the page. We can download pages using the Python request library. The request library will make a GET request to a web server, which will download the HTML contents of a given web page for us. There are several types of requests we can make using requests, of which GET is just one. The URL of our sample website is https://en.wikipedia.org wiki.main underscore page. The task is to download it using request.get method. After running our request, we get a response object. This object has a status code property, which indicates if the page was downloaded successfully, and a content property that gives the HTML code of the web page as output. Moving on to the next slide. Step 3. Introduction to Beautiful SOAP of Page Parsing. We have a lot of Python modules for data extraction. We are going to use Beautiful SOAP for our purpose. Beautiful SOAP is a Python library for pulling data out of HTML and XML files. It needs an input document or URL to create a SOAP object, as it cannot fetch a web page by itself. We have other modules such as regular expression, LXML for the same purpose. We then process the data in CSV or JSON or MySQL format. Requirements: Python IDE, Python modules, Beautiful SOAP library. pip install BS4. This is the input we give. Hashtag import required modules from BS4 input Beautiful SOAP import requests. Hashtag get URL. Page is equal to request.get brackets quotes https colon slash slash en dot wikipedia dot org slash wiki slash main underscore page quotes close bracket. Hashtag scrape web page. SOAP is equals to Beautiful SOAP brackets page dot content comma quotes html dot parser quotes close bracket. Hashtag display scraped data print open bracket soap dot prettify brackets close the bracket. Moving on to the next slide. Here is the output we get from the input we give. As you can see above, we have now downloaded an HTML document. We can use the Beautiful SOAP library to parse this document and extract the text from the p tag. We first have to import the library and create an instance of the Beautiful SOAP class to parse out our document. We can now print out the HTML content of the page formatted nicely using the prettify method on the Beautiful SOAP object. As all the tags are nested, we can move through the structure one level at a time. We can first select all the elements at the top of the page using the children's property of SOAP. Note that children return a list generator, so we need to call the list function. Moving on to the next slide. Step 4. Digging deep into Beautiful SOAP further. 3 features that make Beautiful SOAP so powerful. Beautiful SOAP provides a few simple methods and Pythonic idioms for navigating, searching, and modifying a parse tree. A toolkit for dissecting a document and extracting what you need. It doesn't take much code to write an application. Beautiful SOAP automatically converts incoming documents to Unicode and outgoing documents to UTF-8. You don't have to think about encodings unless the document doesn't specify an encoding, and Beautiful SOAP can't detect one. Then you just have to specify the original encoding. Beautiful SOAP sits on the top of popular Python phasers like LXML and HTML5 lib, allowing you to try out different pricing strategies or trade speed for flexibility. Then we have to just process our data in a proper format such as CSV or JSON or MySQL. Requirements: Python IDE, Python modules, Beautiful Soap library. Moving on to the next slide. This is the input we give for this. Hashtag import required modules from BS4 import Beautiful Soap, import requests, hashtag get URL. Page is equal to request.get open bracket quotes https colon slash slash en.wikipedia.org/wiki slash main underscore page close quote close bracket hashtag script page soap is equal to beautiful soap open bracket page dot content comma quotes html dot parser quotes close bracket list open bracket soap dot children close bracket hashtag find all occurrence of p in html hashtag includes html tags print open bracket soap dot find underscore all open bracket quotes p close bracket again close the bracket print print o bracket quotes slash n quotes close bracket hashtag return only text does not include html tags print bracket soap dot find underscore all bracket in quotes p bracket close bracket 0 dot get underscore text open bracket close bracket. Here is the output we get to the input which we gave. Moving on to the next slide. What we did above was useful for figuring out how to navigate a page, but it took a lot of commands to do something fairly simple. If we want to extract a single tag, we can instead use the find underscore all brackets method, which will find all the instances of a tag on a page. Note that find underscore all bracket returns a list, so we will have to loop through or use indexing to extract text. If you instead only want to find the first instance of a tag, you can use the find method, which will return a single beautiful soap object. Moving on to the next slide. Step 5. Exploring page structure with Chrome DevTools and extracting information. The first thing we will need to do is inspect the page using Chrome DevTools. If you are using another browser, Firefox and Safari have equivalent methods. It is recommended to use Chrome by clicking View Developer Tools. You should end up with a panel at the bottom of the browser like what you see below. Make sure the Elements panel is highlighted. The Elements panel will show you all the HTML tags on the page and let you navigate through them. It's a really handy feature by right-clicking on the page near where it says Extended Forecast. Then clicking Inspection, we will need to open up the tag that contains the text Extended Forecast in the Elements panel. Moving on to the next slide. Here is the analysis by Chrome DevTools. Here is the input we give. Hashtag import required modules from BS4 import beautiful soap import requests. Hashtag get URL page is equal to request.get open bracket quotes http colons //en.wikipedia.org/wiki dot main underscore page quotes close bracket. Hashtag scrape web page soap is equal to beautiful soap open bracket page dot content comma quotes html dot parser close bracket. Hashtag create object is equals to soap dot find bracket id is equals to quotes mp dash left quotes close bracket. Hashtag find tags items is equal to object dot find all find underscore all open bracket class underscore is equal to quotes mp dash h2 close bracket result is equal to items in closed bracket 0 display tags print open bracket result dot prettify open bracket close bracket. Moving on to the next slide. Here is the output we get to the input which we gave in the previous slide. Here we have to select that element that has an ID to it and contains children having the same class. For example, the element with ID MP dash left is a parent element and its nested children have the class MPH2, so we will print the information with the first nested child and prettify it using the prettify function. Moving on to the next slide. Conclusion. We have learned various concepts of web scraping and scraped data from the Wikipedia homepage and parsed it through various web scraping techniques. The article helped us in getting an in-depth idea of web scraping, its comparison with web crawling, and why you should opt for web scraping. We also learned about the components and working of web scraper. Thank you.